Today I'll talk about why Gauss-Seidel methods fails for some systems. A case study with non-diagonal dominant matrix. So the Gauss-Seidel method is a popular iterative technique for solving linear system. However, it doesn't always work, especially when the system matrix doesn't satisfy certain condition. One critical requirement is diagonal dominance. So here the Gauss-Seidel method requires a diagonal dominance matrix where mod of a I greater than equal to summation of other element mod of ij. So where j not is equal to I for all rows. So here is the one critical requirement, that should be the diagonal dominance. Diagonal dominance means that each row, the absolute value of the diagonal element should be greater than or equal to the sum of the absolute value of the other elements in that row. So let's analyze the given system. X plus y plus 54z is equal to 110, 27x plus 6y minus z is equal to 85, and 6x plus 15y plus 2z is equal to 72. So in row 1, the diagonal element is 1 and the sum of the other coefficient is 55, like 1 plus 54, that is 55. So this is not diagonally dominant. Similarly, row 2, the diagonal element is 6, that is less than 27 plus 1, 28. Again, that is also not diagonally dominant. Row 3, so 15 greater than 6 plus 2, 8. So it is a diagonally dominant, but others fail. So based on the our check, the matrix is not diagonally dominant, so we expect the Gauss-Seidel method to fail. So we can use other alternative method, that will be that Jacobi method, LU decomposition, Gauss elimination we can use. Now here to better understand how Gauss-Seidel behaves, let's convert the system into the iterative form. We isolate each variable to form updated equation like x is equal to 110 minus y minus 54z, y is equal to 85 minus 27x plus z by 6, 72 minus 6x minus 15y by 2. This will be used to compute the successive approximation. Now first approximation here is that x is equal to 0, y is equal to 0 and z is equal to 0. Now if we plug that x0, y0 and z0, so x1 will be 110 and then y1 will be, if I plug that updated value of x1 and other, so we will get y1 is minus 480.83 and z1, that is if I plug updated x1 and y1, so that will give something like 3112.23. so these values are already large, so hinting a potential divergence. Now go to the second iteration. So now using that x1, x2 and x1, y1 and z1 value, now we are going to calculate x2. So x2 is, that is a very large number, that is minus 168,439.61, and y2 again, that is very large number, is I am getting from this using that earlier and updated x2 value. So that will give that 75932.88, and z2, so that is very huge number, 378,392.95. so we can see that the values are going rapidly and alternating in sign, a strong indication of divergence. So from that, so after just 2 iterations, so the variable value have explored. Instead of approaching a steady solution, they are oscillating and growing in magnitude. This confirms that Gauss-Seidel method is diverging for the system exactly as predicted due to the lack of diagonal dominance. So from that we can confirm that the Gauss-Seidel method is divergence exponentially.